So a system is just when we have multiple equations, and what we are looking for is the point or points that make them true. So a nonlinear system is just two or more equations in which at least one is nonlinear. That means at least one of them is not a line. The ones we did previously, it was just two lines, and we talked about getting the solution from a graph. When we graphed those two lines, what was the solution?
All real numbers.
Sometimes, if they were the same line, when you looked at a graph, how did you know what the solution was? If you had two lines, you were looking for the point where they met, where they touched each other. So sometimes we had two equations for the same line, so it was all real numbers. Sometimes they met in just a single point. If we had parallel lines, how many times do parallel lines meet? 0, and then it was a no solution. So we are looking for any points that make both equations true. So when we're looking at a graph in which the equations are equal, or where the equations meet if we're looking at the graphs. It might be the case that we just have a single point where they touch. Depending on the types of graphs, we can have many solutions. So a parabola and a line might meet once, they might meet twice. Same thing with two parabolas. Or no solution would just be two graphs that never touch. We're focusing on the graphing of it today. This notes handout has spots where you could draw the graphs if you want to, but I am not going to require it. We are really just using Desmos to get these solutions. So if I told you for number 1, my equations, y equals negative 2x minus 1 and x squared minus 6x plus 3. So we go to Desmos and we graph them. Does everybody have their Chromebook? And we are going to type in both of them. So there's my line. What is x squared minus 6x plus 3? What's that graph going to be? So it's got an x squared. What do we call those from Friday? Quadratic, so it's a parabola. So I have a line and a parabola. How many points, or how many times do these touch? It just looks like 1, doesn't it? You might need to zoom in or something if you can't tell exactly from your graph. It can be tricky sometimes. But we need that point where they touch. And where is it? 2, negative 5. So you kind of can zoom in or out as needed. If you click on it, it's telling me that is the point where they touch. So 2 negative. If you zoom in enough, they aren't really touching there. They're just getting very close to each other. Now, you can check this, especially if you're not really sure, by plugging them back in. If my x is 2, the first one, negative 2 times 2 minus 1 is negative 5. If I put a 2 in here, I get 4 minus 6 times 2 plus 3. And we get negative 5. So you can check from the equations, if you just put them back in, they should work. You could definitely use your graphing calculator for that as well.
Baseball needs to be dismissed at this time. Baseball members need to be dismissed at this time.
So our graph, I'm not going to make you, but you could certainly do that if you wanted. We know how to graph a line, don't we? Y equals negative 2x minus 1, so that'd be a y-intercept of negative 1, slope of 2. So we could graph that, and we just got done graphing our parabolas. We were making T-charts and graphing them, so you could do that as well. Any questions on this one? Let's look at the next one. So we have y equals negative x to the second minus 4x plus 3, and x minus y equals negative 7. Okay, the nice thing about Desmos, it will let you type in x minus y equals negative 7. If you're doing the graphing calculators, it makes you change and solve for y first. How many points do we have this time? 2. So the first one is at negative 4, 3, and the second one is negative 1, 6.
How does this one look to the other?
It just depends on the graphs themselves. So the first one, if we had continued graphing this, so if I did my parabola, axis symmetry opposite of B over 2A, so when we graphed those, we always put the vertex in the middle and did some points on either side. So if I put in a 1, negative 2. If I put in a 2, 7 minus 12 is negative 5, 3. Okay. So if we went through the whole process of graphing this other one. Oh, I graphed my line wrong, didn't I? I graphed slope with positive 2. I'll fix that. So here's our parabola. And then our line, y-intercept of negative 1 and a slope of negative 2. So we use Desmos to shorten it, but we could have done it by hand, and that will maybe show us a little more why we get what we get. So if we go down to an over 1, then we can see it's just because this line is under my parabola right until this point where it touches. So it was just that particular line bumped the side of the parabola. It didn't go through it. It just touched it at one point. Whereas this one, it just cut straight through the middle. Okay, if we look at the next one. What kind of equations are both of these? 2 quadratics, so we have 2 parabolas. Right. So when I look at this, I have 2 parabolas. Do those 2 parabolas touch? No. Now, it will vary depending on the equations. We could have 2 parabolas that do meet each other, but the 2 that I'm looking at do not. And if they don't meet each other, what do we say? No solution. I want you guys to try number 4. All right. So first one, negative negative x to the second plus 4. And the second one, y equals x to the second minus 4x minus 2. So we can see the first point is negative 1, 3, the second, 3, negative 5. It does not matter what order you write those down in. You just have to have them. All right, did everybody get those? All right, set 3. On Friday, we were also talking about exponential equations, so we might have some of those. It's the same idea, so we're still going to just look at our graphs and try to find the points where they meet. So y equals 4, parentheses, 3 over 2. The x. And the second one, x plus 2y equals 20. Now, on my graph, I'm not seeing it right away, so I might have to scroll a little bit. But then we get our intersection is 2, 9. Did everybody get that one to work? And our final one. Y equals negative x to the second minus 8x minus 7, and y equals 18 times 1/3 to the x. Is this the 18 and 1/3 to the x, is that exponential growth or decay? Decay, because it's getting smaller. What's my solution this time? No solution. Those two graphs never meet. All right, are there questions about this? Okay,